We are the Active Wheelchair Group. Our project mentor was Dr. Ali Amiri, and our project sponsor is McKenna Dinkle. When our friend Kenna started complaining about the design and construction for her wheelchair, we decided that we could put our minds together and make her a better one. The main complaints about her current wheelchair are a lack of frame strength, lack of stability, and that the chair is too small overall. After many rounds of concept designs, we created our final model in Creo. Our main design focus included a frame that won't easily deform from being dropped or impacting objects, a full assembly that will survive her active lifestyle, and a frame that will be better suited for her long legs and back injury. After modeling was completed, we performed FEA testing of our 3D model to ensure that the frame would withstand overloads and impact scenarios with minimal to no deformation.
For manufacturing the metal components, sheet metal parts were cut with the help of the IME manufacturing department. A plasma cutter was used to cut the fins, bench supports, and the rotation brackets. For the mainframe fabrication, the aluminum tubes were bent, cut to size, then manually notched to ensure a tight fitment, which maximized the surface contact for welding. The tube welding involved using a MIG welder first, then using a TIG welder to reduce the weld's volume at some of the joints.
For the manufacturing of the seat, we laser cut, glued, and sanded the seat back so we could have a seat that was contoured perfectly to fit Kenna's spinal injury needs. Next, we moved on to paint selection of the chair. We tested different paints and sealers for any reactions and durability. Then we cleaned, primed, and painted the wheelchair. For the painting, we chose a spray automotive and hung the parts for the painting for even coat distribution. After the chair was fully painted and cured, we assembled all the parts together and calibrated the wheel locations and the axle length for both 0 and 6 degree camber. We also ensured the backrest was fully functional and the cushions were in the proper location.
We decided to perform a motion study to compare the speed and stability of the original wheelchair to our new design. We performed the same tests in both semesters to compare our results. To do the 3D motion capture, we attached reflective markers to landmarks on her upper body and parts of the wheelchair. These markers are tracked by cameras around the room, resulting in points in 3D space that were used to find the values we were interested in. There were also force plates in the floor of the measurement area that output force vectors. We had Kenna perform a constant speed test and a test where she picked up different loads from the side of her chair by leaning over. These tests allowed us to prove that our design was more stable than her original chair.